All right, this might be one of the more dense walkthroughs in the series about Claude Code, and it's actually probably one of the only ones where we're not really going to talk too much about Claude Code, although you will learn how to work with Claude Code to sort of fill in your gaps of where this walkthrough falls short or stops. Then after that, you can work with Claude Code. But this video is all about Git. And I debated whether to include this or not, but I think it's so crucial and so essential, and it really sets a strong foundation upon which you can build your workflows with Claude Code and your whole system with Claude Code so much better and so much more resilient that I think sort of this, side quest of like learning how to use Git is actually very important, and I think it's going to make a huge difference. So anyways, let's talk about Git. What is Git, right? In simple terms, and by the way, this diagram probably doesn't make sense unless you already know Git, but in simple terms, Git is like version control in your doc software, Google Docs, Microsoft, whatever it is. It's like that, where you save multiple versions over time or at the same time, and it controls that version. You're able to go back to any previous versions, right? The big difference with Git is that if Microsoft and Google's doc versioning is on a single document, Git actually works at a folder level, at a directory level. So it actually takes a snapshot and version controls all of the files that are in the folder, which makes it so much more powerful when you start thinking about use cases around like context repos, for example. You might only change one markdown file in a context repo to say, oh, we have a new updated persona, for example, right? But maybe if you have a new updated persona file, then that has downstream effect on maybe your campaign angles or the pain points that you cover, how you message them, right? And so you might have knock-on effect on other files, and all of those other files change as well, right? Well, what Git does is look at all of those changes and take a snapshot of it and saves it as a version so that you can always go back to, well, actually that persona update that we made was not accurate. It was a hypothesis. We tested it. It's not correct. We should probably roll back to what we had before. Well, how do we do that? We can use Git to look up the version that you had saved right before making that change, go back to it, and all of the other files that you made changes to with the update to the persona. So the pain points, the campaign angle, right? All of those can be rolled back at the same time. So it's really, really powerful stuff. And we won't get into it today, but also what Git does is, because you have sort of a remote Git version control in the cloud, it unlocks multiplayer mode for working with Claude Code, right? So obviously it's super helpful even in single player mode where you're the only one using Git. You have all of the versions that you can refer back to if something goes awry. But if you want to start involving your teammates into Git, it's also super helpful because they can also access the same version of all the files and pull it into their local laptop, to their personal laptop to start working on it themselves, right? So it really enables collaboration and to make sure that everyone's aligned in terms of what's the latest updated version of this file, that file. So it's really, really powerful, but we won't cover that today. We'll just talk mostly about single player mode. Cool. So, how do we set this up? Okay, so let's go to Cursor or your IDE or your terminal, right? And what you'll type in is brew install git, which installs Git through Homebrew. And if you don't have Homebrew installed, I think it comes with macOS, but if you don't, just ask Claude, right? Ask Claude, hey, I'm supposed to use brew install Git. It's not working. This is the error message that I'm getting. What's happening? What do I need to do? Right? Easy enough. I already have Git installed. So if you have Git installed and you want to check, the best way to do it is just to type in git -- version. And it'll tell you what Git version you have. I actually have an outdated version. So if I do brew install Git, it will go ahead and update to the latest version. Cool. So let me look at this now. So Git, if I do a version again, now you can see, I think it's hidden behind my camera here, but you can see that the version will have 2.5, 2.0. Great. Okay, so it's been installed, in my case, upgraded. So that's how you install Git. And then you need to configure a couple things. So you need to do git config global. So this applies to all gits that are created, so all version controls that are created, machine. You need to type in username, and you might do something like your name, right? And you'll do the same thing, but instead of username, I'm going to say user email. And this is, I might do like joe@root.com, let's say, for example, or something like that, right? And I won't enter it. But basically what it does is it tells Git, who are you that is making changes to these different versions, because Git needs to track who the person was behind making these changes. Especially useful, again, in multiplayer mode, right? If your colleague changed something to the files, they want to know that person was responsible for these changes. Again, it leaves a really good audit trail, and so this is why we're doing git config, so username and user email. So once you've set those up, then what we're going to do is brew, again, install GH. GH stands for GitHub. GitHub is the most popular cloud service that works with Git, and it's essentially free for any single developers, and the feature set that they provide is just amazing. And so I wouldn't even bother looking anywhere else. I would just use GitHub. So brew install GitHub GH allows you command line interface to work with GitHub. So and this is really powerful when you combine it with Claude Code, and you'll see what that looks like. So okay, again, I had it installed, but it was outdated, so you upgraded. Great. And then what you need to do is GH auth login. When you do this, it'll actually say, where do you use GitHub? GitHub.com. GitHub.com, typing GitHub.com. Use, what is your preferred protocol? Select HTTPS. Authenticate Git with your GitHub credentials. Yes. So type capital Y, enter. Login with a web browser is how I would like to authenticate with GitHub CLI. And you copy this code that they give you, which then brings up this window to log in, and I can continue, but I've already logged in, so I'm not going to do it. But if you continue, then you might have to like identify, like do a 2FA authentication, maybe through your email or something. I have a mobile app on my phone, so it'll ask for that. But that's currently serving as my camera, so I'm not going to touch it. But basically, you just log in, and that's it. Oh, by the way, you might actually have to. You wouldn't have. I forgot. You wouldn't have a GitHub account unless you've already signed up for it, right? So go to GitHub. Go to github.com and sign up. It's all free. Put in your email, password, username, your country, and then just sign up. And then you can log in when you go to this workflow here, right? Great. So now I'm going to show you how to use GitHub to create a repo, which is the short for repository, and then how to basically get access to that repo in the cloud on your local machine, on your laptop, on your MacBook or Mac. Work on it and then keep updating. So like actually use version control, right? So we'll go to the more fun stuff, if we can call it that. And like I said, I apologize for how dense and technical this might seem, but it is so important that you learn sort of the essentials and the foundations of how Git works, so that you can work with Claude Code to do a bunch of stuff, and it really unlocks a lot of things. And I think this is tangential, but I did want to bring up a point, which is that Claude Code can't do everything for you, right? It can like help you. It can do things on its own when you give it clear guidelines and guardrails and ways to iterate on things, right? But ultimately, like everything is still driven by you, right? And why I bring up that point is like you could maybe get away with not learning Git by like installing everything and then just getting Claude to try to do everything for you. But literally spending 30 minutes or maybe an hour of just sitting down and understanding the basics of Git, and then being able to now use that language and that mental model that you have around Git to work with Claude Code will save you so much pain and frustration down the line. And also it'll help you, like you'll actually learn through that process instead of outsourcing everything to Claude, right? And so I think that is really important, not just in Git, but in everything else, right? Like there are things that you'll probably never have to learn that you can just completely outsource to Claude, do it once and that's okay. But Git is something that you're just going to use all the time. If you start using Claude Code, that you should make that upfront investment to learn how to do it. Okay, I'll stop because I've literally made a similar point about how essential Git is like 3 different times now in this video. So I will not mention why this is so important anymore. Okay. So what we're going to do is, let's say that you've signed up for Git and you've authenticated, right? You've logged into Git on your in your terminal. So now that now your terminal, your machine is using GitHub as your main Git source or platform, right? So let's assume that we're there. You'll be signed into something like this. And what you want to do is you can either go to repositories or you can go to new repository. That's what we're doing here. So we'll create a new repository, right? I will actually save it in the workflow code. And let's name it Git walkthrough example, right? And I'll just type in, I'm not going to even type that in. Okay, I'm just going to create a repository. Perfect. So I've created a repository, and you can see that because it says Git walkthrough example right here, right? And what I'm going to do now is you've created a Git repository, which is like this folder where version control is going to be applied, but you need this on your local machine as well to kind of create that linkage, right? And to be able to work on it on your local machine. And so what you need to do is you need to copy this part right here. Quick, if you've done this kind of thing before, and then it says HTTPS or SSH, we said HTTPS, and you can copy this thing where it says git@github.com, and then this part will change depending on what your account name is, and then what name you gave your repo, right? When you first create a repo, nothing's going to be in it, and just copy this right here, okay? And then we're going to go back to our IDE. And if you're using something like, if you're using something like Cursor or VS Code, you can just click on Clone Repo when you open a new window. Do you see that? Clone Repo here. And it'll ask you for, clone from GitHub, and then you can literally just paste this part in here, and it'll do that for you. Or you could go to where you want to save all of your repos, and I recommend having sort of a parent directory called repos or whatever. I think mine's in documents, Odin repos, right? And you can do git clone, because you're cloning what you've created inside of GitHub, and then paste this part here, which is git@github.com, the workflow code, git walkthrough example.git. And command V is the key combination that I used to clone this, right? So git clone, there we go. But I will use, actually, I'll use this. Great. So cloning into git walkthrough example. And because we were in the repos folder, that's where this new folder that's going to be named whatever your project name is, which is git walkthrough example, has been created. You appear to have cloned an empty repository. That's totally fine. So now open this. There we go. Might have lost my Claude session, so let's do this again. What I'm going to do is just work with Claude to create some dummy files, right? But I'll show you how the different Git workflows work. And in fact, what I'll do right now is revisit the that diagram that I said don't worry about, not to worry about it, right? So let's see. Okay, how Git works. This is a random medium article. Look for how Git works, a visual guide with code. I'll post a link to this on YouTube so that if you want to read it, you can. But I just saw this and I thought this was really good. So basically, here's what's going on. You have a remote repository, which we used GitHub to set up, right? So remote repository here. And then you have your local repository, which is on your local machine, the computer that you're on, right? And what you're doing is, sorry. Yeah, no, local repository is your machine, but they use the concept of workspace, which is your folder, right? So your folder, in our case, that was, I think, git-walkthrough-example, right? You have a bunch of files, and what you can do is you first start with a command called git add. So you add a certain number of files or all the files that have been changed, right? And we call this staging the files in Git. And once you've staged them, you can commit the staged files into your local repository, and then you can push them into GitHub to save that snapshot, right? The mental model here, there's a lot of different analogies that you can use, but here's how I think about it. Sorry. So think of a commit as a box, right? Where you're going to ship that box to someone else and you're determining what to put inside that box. What you decide to put into that box is git add, and you're staging those things. So let's say it's a bunch of documents. You're deciding which documents should I put into this box, which is a commit. And so you're going to select a bunch of boxes, and then you're going to select a bunch of documents, put them into a box, commit it, and then you're going to send it, which is git push. That box gets stored away in a warehouse, and you know exactly what's in that box, right? And the reason why we have this middle staging part is for the reason that I mentioned in the example of, like, if you have a context repo and you want to change your persona, but that has some downstream consequences on some of the other files and you want to update those as well, well, you probably want to group all of those changes to the persona file, to the campaign angle file, to the pain points file, let's say, right? Because they all share the same root cause for why the files were changed. The files were changed because you decided to test this new hypothesis for a new persona, right? Well, if you put all of those documents into one box, it's actually very helpful because you can just say this box is for the persona change. And if you had to roll back to it, you could just look at going back to what that box looked like right before you packaged it up and sent it. And so that's why this staging part is useful, because you can group all of the files that should be in one box because they're maybe doing the same task from the same project or whatever it is, right? But let's say, for example, you made that change to persona, and then you also decide to change the system prompt that goes to Claude Code. You decide to change Claude.md that had nothing to do with that persona change, right? If that persona change was also in the same box, now those two completely different things have been saved in the same box or committed into the same commit, and it's difficult to have a checkpoint that will only change the things that will only roll back the changes that you made to the persona and relevant files, right? And so that's why I use this analogy of like boxes, because you want to group the different files that share a similar dimension or similar trait into one box. Enough of this. I think it'll be easier when you see this in action. Okay. So what I'm going to do is I'm going to create a new file. I could use Claude Code, but I'm just going to do it really quickly. So I'm just going to create a new file called overview.md. This is an example for my Git walkthrough video, let's say, right? I will save it. You can see here it's green because it's untracked. What I'm actually going to do is use the commands, and then I'll also bring in Claude when I need to. But Git walkthrough example. Now what I can do is I can git add overview.md, right? So I didn't get an error message, which means that it worked. And I can look at git status, and you'll see that there's changes to be committed. Again, remember, add is the first part that we do to say, okay, these are the files I think are going to go into this box. And only when you commit it does it actually go into the box, right? So then I can say, okay, cool. I'm going to commit this file now. So I can say git commit. And it's different when you do commit versus add. You don't have to specify the files because all the files that have been added are in like the staging area. So Git knows which files have been staged. So I don't have to actually specify which files I'm going to commit. They're all in the box already, let's say. And commit, I guess the better analogy is taping the box shut is what's actually happening. So the files are already in the box, so you don't actually need to say, these are the files that I'm going to commit. So git commit, and then -m for message. So I'll say created overview file, right? And you'll see what this looks like, but it's helpful to create a commit message. It's like a label that you put on the box, right? Like, what is this commit about? Well, I created an overview file is what I'm saying. And oftentimes just using Claude Code to do this is like the easiest way to do this. All right, so I'm going to commit this. And now you can see that there is like a bunch of this stuff that you probably don't understand, but it basically says there's been a commit to the main branch, and this is the hash value of that commit. It's a unique identifier of the commit of the box, so like a tracking number for the box, let's say, and it says create an overview file. That was the message, right? And so if I go to git log, I can see that there is this commit right here, right? Now, if I type in git status, I don't think this is going to say anything now. It'll say git status, because there's nothing to commit now. The file has been committed already, so there's nothing to file, and I'm going to do a git push. All right, so what did that do? Git push, if you refer back to the diagram, git push is here where it's still only on my local machine, and when you push it, it goes into GitHub. So let's see if this actually worked. Okay, so I need to refresh this page. Again, we're in the same repo. If I go here now, you'll see that there is an overview file right here, right? So if I click into that, you can see that it says this is an example for my Git walkthrough video, right? So it's been committed, it's been pushed, it's in the remote repo now, which is great because now I can always refer back to it. And you can also see that there's one commit. So you can click on it, look at all of the commits in a sort of a timeline, and you can revisit what the repo looked like at any given point when you made those commits, right? So commits are like your checkpoints that you want to do regularly so that you can always go back to those and see what it looked like. So let me just do a few more, right? So let's say, for example, I'm going to actually say, this is an example markdown file. So I edited it here, right? And I'm actually going to create a new file called jokes.md. And I'll ask Claude Code to say, create a silly chicken joke in jokes.md. Okay, so it's reading it. Great. So it created a silly joke. Why did the chicken join the band? Because it already had the drumsticks. Great. So I'll save this. And now I'm going to do the same thing where I'm going to say git add. And I have to add the modified changes as well. So I have to say overview md and the new file, jokes.md, right? Now, this might become cumbersome to list out all of the files, right? So sometimes what I do is you can just type in git add dot, so just a period, which means any files that have been created, modified, deleted, we're just adding all of those changes in one go. So when I press enter here, git add dot, the colors will go away because this green, which signifies new file, and this yellow, which signifies modified file, will have been added and staged. So I'll do add dot. Oh, sorry, that changes when you commit. So even I get confused. So git commit m, and I'll say jokes added, overview modified. Let's say, for example. Great. Now the colors went away. That's been committed, and now I can do git push. Right. So let's refresh this again. Now you can see jokes and overview. And if I go into overview, you will see that now it has that edit markdown file, which was added in the last commit. And if I go to jokes.md, it has this joke here, right? Let's say, you can, by the way, edit it inside of GitHub for quick edits. So that's what I'm going to do this time. Give me another joke. All right, added another one, and give me one more, because I'm going to show you two more examples. Okay, so Claude actually went ahead and made those changes directly into the file, right? What I'm going to do is actually delete these. And then what I'm going to do is I'm going to save this here. I'm going to commit this change. So GitHub allows you to commit that change right away. It's not adding it, it's committing it, right? So I'm going to commit. And so just like we did in inside of our terminal, we have to write a commit message, right? Add new chicken joke to jokes.md, commit direct, okay, commit changes. Okay, done. Now what's happened is your remote repo is ahead by one commit, meaning it has changes in the remote repo, in this repo here, and your local repository is actually behind, right? Well, and this is often the case when you start collaborating with other people on the same repo, right? And so now what you can do is go here and you can say git, in the terminal, you can say git fetch. What git fetch does is, I think it shows it here. Yeah, what git fetch does is it pulls any changes, any commits from the remote repository into the local repository here. So you actually still don't see it, the change that we made inside of git here, because it's in the repository, but it hasn't been pulled into your workspace yet, right? And so now what you can do is after git fetch, you can do git merge. And when you do git merge, is when it brings it into your workspace from your local repository, right here, git merge, right? And now you can see, why don't chickens like people? They beat eggs, which was what we had added in the repo, right? So that's how you would pull any changes from the repo, which is not really a big problem if you're doing single player mode. But if you start bringing in other team members, obviously they're going to make some changes and you want to be able to pull that into your repo. Last one, we'll do, said this one. So we'll make this last joke. Okay, so I'll commit this change, edit a new joke about a chicken and a salad, commit changes. Last time we did git fetch and git merge, right? You can combine these two by using a git pull, which is basically, running these two together. So you can just say git pull, and what we'll see this time is the commit that was made in the remote repository gets pulled straight in through your local repository all the way into your workspace. So if I do this, git pull, there we go. You can see that it's been pulled in here now in jokes, right? And so this covers all of the basic commands that you should know in terms of Git. And again, this mental or this visualization helps. So I'll link to this. And then also the mental model of like putting documents into a box, sealing it, and then sending it off, hopefully helps explain sort of how Git works, right? One last thing I think that we should absolutely cover is sometimes you're going to have sensitive information that you don't necessarily want to show to other people who have access to this repo. So if you make your repo public, so you can do that here. If you go to settings, change repo visibility, right? You can make it public, change visibility. If it's public, anyone has access to it. If it's visible, it's only accessible to people that you shared it with, right? But even then, you might not want, you never want to save like API keys in here, for example, right? If you're starting to use Claude Code for things like that, for writing scripts to pull information from an API endpoint, you might have an API key and you do want to save it, but you don't want to necessarily push it to the remote repo because there's literally bots that scrape all of GitHub every so often to see if they can get free API keys and use your credits. And so in that case, if there's sensitive information, what you can do is create, so I'll create a new secret file, right? So I'll say secret.md, and I'll say this is a secret, right? I don't want to share this with anyone who has access to the repo. What I can do then is create a new file called .gitignore. .gitignore, one word. If I do that, I can now tell it what to ignore. So I can say secret.md should be ignored, and I'll save that, right? And now what I do when I do git add and add everything and git commit, and I'll say created git ignore, and I'll git push. Now you'll see in the repo that git ignore has been added, right? But secret MD is not there. So this way you keep all of your secret in here, right? API keys, whatever it is, but it never gets stored in Git. It just gets ignored. So this is a best practice around your secret management, like API keys, your authentication, and whatever else that is sensitive information. Always make sure to create a git ignore, save those in your secret dot whatever file, right? And then and add those to your gitignore file. And then lastly, now that you have sort of a foundational knowledge of Git, you can start working with Claude and say, can you create a new blank file called blank.md and use GHCLI, so that's GitHub command line interface, to commit and push to the remote repo. So it'll create a blank.md. It's been created. It's blank. And then now it knows how to use all of these, right? So it looks up what the remote repo's name is, the link is. It looks at what the difference is. So like Claude knows what to do here now. And it'll say, okay, I'm going to run these commands. And I'll say, yeah, sounds good. And it just ran that command on my behalf. And it'll also push it. So I can push. And you'll see that I just used Claude to create a blank.md file, right? But obviously, these operations, you need to be careful, right? Because you could overwrite, you could like remove all of the Git history, the commit history, for example, right? So it's helpful to have this foundational knowledge before you start working with Claude to like delegate some of this work. Okay, so that covers the Git basics as it pertains to how to work with Claude Code and use Git. And we haven't covered, like we've probably covered 5% of Git, right? Like the 5% that is crucial, but there's a whole bunch of other stuff like multiplayer mode, there's branches, pull requests. Those, really important, I use it all the time, but probably sits just outside of this the scope of this series. And so I'll leave that to you to sort of explore on your own if you're interested. But hopefully this helps set you up for success as you start using Git. And I highly, highly recommend using it as you start getting more into Claude Code. Thanks.